Yeah, I think it's better to put the record. Okay.
Deepak, I can see your screen already.
You can see not or
I can. I see your screen, Philippe at Philippe Alienware.
yes,
That's probably the reason.
Great.
So I can see it.
Great. So let me just open the slides, Firefox. So if any of you try to install it and deal with some problems like this, I would say like first and foremost, the main problem that you have to face is the internet connection. Okay, the packages are quite big, and you need some reliable internet to download it and properly install this. The second problem that can arise from this is like the Conda channel that I recommended. It is a quite old Conda channel. Or you can just omit the Conda channel, like this Conda equals 4.6.14. You can just omit this and try to install it, okay? And third, it will be like, if you download most recently, if you download today, you are downloading the recent Anaconda package management, okay? Because if you download the older one, it might not have the FastAI version 2 available for the channels or anything about this. These are the main problems that you can face. Another thing is we have to decide how we are going to share the data set for you to train in the models, because tomorrow I will show you how to generate the data sets and how we are going to deal with it. And in the afternoon, we are going to start to build our machine learning to classify. I mean, we'll start to build the data set for you, and you start to build in the machine learning model to classify. And I have one data set already generated about this, and I can share for you to train. And I have another data set, which is the black box data set, which I give to you. I will not say nothing about the data set. I will say, okay, you already trained a machine learning. Can you detect some events in this? Which will be really interesting exercise for you. It will be like, which is basically doing the research about this. Okay, and this is like the main motivation for our course here, or this workshop. Okay, so let me open when we stop this morning here. See, and okay. If you already started, can you, Alexandre, can you help me to at least remove this? Yes, that bar, because it's. You cannot. Okay. I'll go to that way. Sure. Okay. Is everyone seeing here? One good thing for this, I mean, I can even run these cells here, like so, and we can import and do this. Luckily, if you already installed the FastAI, if you're already running, I'm going to explore a little bit on a problem, because if you're going to search for tutorials on machine learning and deep learning stuff, the first thing you're going to see is the MNIST dataset. Okay, what is the MNIST dataset? Is the handwritten numbers that you are built to classify, and this is like the most classical problem, and they do this. The data is amazing because you have like all of these classes of number, like from 0 to 9, and you can build a very crazy machine to identify these. But the thing is, these things are so common, and people are building so crazy models on this. If you don't get 99% of accuracy on this, you are getting something wrong. You are doing something really, really wrong. So this is kind of like become like the standard, but it's so easy for the machines to figure out about this. It becomes like a useless point. So what we are going to do this in this hand session is going to explore a little bit more more tricky data than classify numbers. We are going to classify kittens and puppies. Okay, so this is, I kind of like it, and it's really way to understand and also a really challenging problem to do this. If you think about like the program perspectives on this, it's not that easy task to develop an algorithm that can figure out about like, okay, this image is from a cat and this image is from a dog. So we installed the FastAI, we import everything related to the computer vision problems. It's like this library here, that's vision.all. We import everything that we need. I'm having some echo, so I try to, okay. And we will create this object here. If you create this and you run on your computer, you see it will build this kind of path like this. So as we did this morning, this class here called untar data, you create a folder. If the destination doesn't exist, download the data set, the PETS data set from Oxford, on tar, unpack this, and store on our machine or your Google instance if you're running this on a Google instance. And this is made automatically for you. So this is kind of like a magic, like the guy is saying here. So, but I mean, don't worry, this is not like black magic. You can also implement the same function, the very same function by yourself. And it's a really, really good exercise to do this. I mean, I highly recommend it to you. Just like take the functions from the FastAI, the classes, and try to build by yourself. Try to think about like these problems and try to build this. If you're willing to do this kind of exercise, I mean, it's really amazing because you are not only building a library for yourself, but you got like more and more confidence on making this kind of function, making this kind of a program routine for you. So one thing that when we read the documentation from the data set, from the past data set, it says that's like for the labels, like we have the image, we have the label is like the name of the image. For cats, all the letters are capital, and for dogs, the letters aren't capital, okay? So we are going to build a model, as I said before, which will be able to see a picture and it will say like, okay, this is a cat and this is a dog. It's not like the most useful model I see, but I mean, it's an exercise, okay? Later during this week, we are going to build like really useful models that we can estimate parameters or we can classify events that you want. But as a first introduction, as a way to introduce this, it's the best we can get, the best we can understand. And let me just have some more very quickly. If you have any question, please interrupt me. I can see if you're raising hands.
Just very quickly.
Yeah.
This is just to let you know that at least here in the room it's taking some time. So I'm loading these X images.
Yes.
And it's 79%.
You too.
And I start loading it when you start talking.
Okay.
So, or as soon as you put it.
Yeah.
So for you to.
So if I try to run this immediately and if your internet are not so reliable so fast, I would say like just watch right now and download it from the Git. Like you can download it from here, the lectures. Like the, okay. Yeah. You can see here you have like the GitHub of the lectures. You can just go to the notebooks and you can download it. We are in this lecture here, Intro to FastAI. You can download this notebook if you have the FastAI installed and everything. You can run the notebooks, or you can go any order that you want, that you feel adventurous and to explore. You can do whatever you want. So if you are trying to run at the same time that I'm explaining, you might encounter this kind of delay time that I do this. But I say like, let's just see right now, and you can run this afterwards, or you can try to do this by yourself. So I think that we send an email with the link from the Git. I recommend it. to get. And if you can, just give a like or just follow me or anything like this. We have like not only this kit, we have like a lot of different stuff from here. And yes, you can learn a lot on this, okay? Especially this data set, COVID, that we're working on with the people in Valencia. I'm doing this. So let me just close here. Okay. So what we are going to do? First, we are going to need how we give the data to the model. I mean, I like to work as this way because once we are read, like we spend 92% of the time building the data set, building how to give this kind of images, the data to the machine to learn, because the machine can learn this extremely fast. And we spend only 80% of the time tweaking and changing some parameters with the model, the machine learning model itself. So one of my main pains, and one thing that I really like to say to people, to students that are venturing about this, is just like, okay, the best way to learn is by committing mistakes. But the even better way to learn is just like to look at the other mistakes. So one of my main mistakes during this machine learning, when I was learning, is how to properly load the data, give the data, split it to training and test and normalize, all of these kind of things. And it makes you like really, really painful to learn about this. So FastAI comes to help this with this really, really amazing class that's called image data loaders. So this is a special class that has like some sub functions that you can just like, okay, my folder, my files, my image files are stored in this folder that we defined before here. Let's call it the path. Remember that we have this path here, and you have like the images are stored on this. And the labels of these images, it is defined by this. I mean, I'm defining two classes. If it's a cat or it's a dog. If the name of the image is a upper capital, it is a cat. If it's a lower letter, it's a dog. So I'm saying that's like the label function here that I'm building here. It will give it to the machine to say like, okay, this image, the name of the image has capital letters, so it's an image of a dog. If not, the image is a cat. So by doing this, we are already like loading the images and put the labels. This used to be a really painful task to do this. This is not like very, very trivial. And FastAI already makes this to you. You just need to be a little bit smart about this. This function here, this get image files, is another function from FastAI, which makes this kind of thing, which it takes like, okay, it takes a path, where is the image, go there, grab the image, convert it to a tensor, and do whatever we want to this tensor, to this kind of thing. Why to a tensor? We are going to see in a moment, okay? Another thing it is the validation per second, like this, okay? When you are building machine learning models, when you're doing this kind of stuff, ideally you have like a training data set where you have like a lot of images that the machine learning will see and try to get some predictions, and you say like, okay, I think with 92% of confidence this is a cat image. If it is a cat image, the machine gets a success and can move on to the next one. If it's not, the machine gets punished, and we run the back propagation. So this training data set, the machine has to know what are the images. So you are not going to evaluate your model on a set that you already know the answer. You have to evaluate, I mean, you have to check if your model can learn the things properly on a set that he doesn't have access to these labels, to this image name. So we usually what we do, we divide in 8% for training, that the machine will know the labels for this and you try to adjust, and 20% for the test set, for the validation, where the machine will never know the labels. So if the machine can perform very well on this validation data set, it's give me an indication that my model is generalizing very well. My model is like is giving good predictions on data that he never saw before, and also the data he never get access to the answer like this. So that's why we split in the training and the test data set. And FastAI again give us this option here. You can divide like in training, validation, test set. You can do a lot of stuff on this. The seed is like, because we are splitting this data randomly, we are taking like the data and we are shuffling, and we are just like, okay, dividing 20% of the images as a validation and 80% of the images as a training set. And all of these images are shuffled. We are imposing some random choice on this. And ideally, I want to reproduce some of the models that are outside of this. And so, some machine learning models are very sensitive to the shuffling of this kind of thing. And it can even be sensitive to the order that the machine are shown, the images are shown to the machine. And you always have to keep in mind on this. And one way to keep track the reproducibility is a word? Yes. Is by setting these seeds, setting this random number generator. So you're setting here for the number 42. You can set for any number that you want, or a string, or anything that you wish. I chose 42 because it's the answer for everything, okay? And another very, very important from this, here you have like to keep in mind, is the size of the image, because we are going to see in the next slides that not all of these images has the same size. Some images are like a 500 by 1600 pixels, another image are for cameras, and all of this kind of things. And when we are building machine learning models, we are building with a fixed number of dimensions. We are building like for the vision, we are considered only a fixed size of dimension. Why, you might ask? Because of memory size. I mean, we are constrained with the biggest constraint on machine learning in the current time is the size of these models. These models are becoming like a huge, very, very big, and you have limited size of memory, especially on a GPU, and you have to deal with this. One way to deal with this is to randomly cropping and resizing the images that they are given to the model. In my case, I'm resizing the image, that any image that is going to appear, it will be resized to the 224 by 224 pixels. I'm not sure if your computers can handle this, I mean, can handle even bigger or smaller, but this is like a medium term for this kind of a resize. We can also, we are going like in this week, we're going to explore another kind of transformations that's called the data augmentations, where we can like give some randomness to the machine as well. And we can give like in this kind of a Eten transformation field here. So here it's like that's a really, really good thing that I like to do to Jupyter dataset this morning. Once you get like import a class and you have like some questions about the functions, you can always go to the documentations. You can always go to some YouTube tutorial of an Indian guy or anything like this. It has a lot of this. Or you can just like, okay, just ask to the Jupyter. You can put like these 2 question marks and it will open a doc string. And in this doc string, in the case like 2 question marks, it will open the code, the source code for the class like this. And all of this source code that has all of this information, of course, I mean, you open this, you kind of like get scared about this. But once you get used to this, you start to become like a very, very confident on this. Okay, I have in this class image data folder, we have like this function that we are using here, like from name, I mean, in that case, I'm from name function, but we can also have like from folders or like from path function here. I think that is because it's truncated, so you cannot see all the doc string. But in the Jupyter Notebook, when you do this, you can always like move back and forth and see about this. And this is really good because you are seeing what the things are doing, and you can also like take these ideas and apply for the problems that you have, for the problems that you want. So as an example, one problem that I have right now, I have like to give two kind of images to the machine. One very noise, we're going to see in the last lecture, and one that is really clean of noise, anything like this. And I want the machine try to learn how to remove all the garbage stuff and only give me the good thing, the good part of this. And lo and behold, the machine can do this very, very well. So, and I have like to build by myself an image data loader that gives the machine these kind of things, like a input image and a target image. So I build this using these kind of ideas that they have, like, okay, I try to implement and try to modify this. So again, if I want to say, okay, this is a really funny function.
Can I interrupt just?
Yes.
I missed a little bit of what is the usefulness of this last step of the image data loaders.
Which one?
The very last step that you...
The resize.
No. After this input 9, the image data loaders.
Oh, the image data loaders.
Why would we use this?
What do you mean?
What is the usefulness of this?
Oh, these image data loaders. It will wrap everything that you needed to grab the image, normalize, resize, and do this, and you make it ready for you to give to the machine learning model. It will be. This is the main usefulness of this. Right? It is wrap everything that you need to prepare for the machine learning, so you don't have to worry at all on this part of the data set of this. This saves you, as I said, like this saves you 92% of the job for doing machine learning stuff. Believe me, this is the main reason that I like so much the fast AI stuff. So, and you can also like try to, if you have like not an image data set, but you have an image and a time series, you can build the same kind of thing. You can build the same kind of stuff using this. So, and now we can, okay, we are read. Oh, this is, okay. Okay, and once we create these data loaders, we can also like have a peek inside what are these data loaders, what are these things are doing. And you have like this very convenient function that's called show batch, that will grab one random batch from my data set. We are going to see why the data is split in batches, why we are going to see this. It always has a reason, and we are going to explore this. The main reason is because of the stochastic gradient descent. And to check if my data set is working properly and they are doing the things that I want, I can give this function like show batch and to grab one random batch and put on the screen for me to check this. So what this thing is taking like the images from dogs, like really cute images from this, and the labels you see on the top, it says like false, true, false. If it's a cat, it's true. If it's not, it's false. Okay. So we are all set and done with the data. So we can move on to the deep learning stuff, like to the meats and potatoes, like this. Okay, any question like this? We are also going to explore a little bit more on the data part in the next sessions, in the next lectures, and you'll see a little bit more about this. So now we have like we have done with this job. We can move on to the machine learning part, like to build the neural net architectures like this. So FastAI has lots of classes, and one of these classes is called the CNN Learn, which is a specific class that you give the data that you already built, the data loaders that you build. You say like, okay, I want some pre-trained architecture, like these classic architectures that we have. We have many different kinds of architectures already like saved on the fast AI. In that case, I'm giving like this HasNet 34. It is a 34 layers model. It's a really deep convolutional neural network. I mean, before that, it was VGG 16. It was like the deepest one on the very old times of 2015, like this. And the people are saying that's like impossible to train even deeper neural nets. So, which comes these people from, I think that was from Facebook and from Google as well. And they show that's like these rigidal neural networks that you can, the machine can figure out by itself how deep it can go by doing this. And these are like really, really good ones. This won the ImageNet competitions at the 2016, I think. So this CNN learn, it will like grab the data, grab the architecture that I want, and some metrics if I want to give like some metrics to see how good my model is. In my case, I'm giving like the error rate. The error rate is just like the percentage of the time that my model fails to predict like this. This is like, it's a really good metrics that's like give you an average insight of how well your model are performing on this. And you just do this and create for yourself. I mean, you don't have to deal with any kind of a tensor dimension or tensor normalization or batch norm or anything like this. It builds you for free, let's say. And this is like really magic stuff. And you can have a check on this class like this. So where we have like the data loaders, one of the main parameters are the data loaders, the architecture, and the metrics that you can give like this. But you can also like, okay, give some loss function that you want to test, some target range that's really useful. This parameter here is really useful for regression models that we also have like to work a lot on this. Number of outputs also, if you can give, or the machine can figure out by itself. The fast AI is really smart because it can even figure out this kind of stuff, and you have like to not worry about this. Another thing that he's automatically putting is the optimizer function, the optimizer here. Why he put add-ons? Because add-ons is like the basic one optimizers that we're going to explore in the next lectures, and is the one that works every time. So if I'm going to build any kind of model, try to start with simple stuff. I mean, try to with the very basic. And the basic stuff is the add-on optimizer. It's really quick, it's really fast, and it works very, very well. But maybe for your data or for problems that you are using, it's not like the most suitable one for you. Okay? And you can also give like parameters like the learning rate, some callbacks that we have also as well. Some of these callbacks can be like save models, save the best models during the training phase or the evaluation phases, or you can just like put some other callbacks that might be interesting for you that you want to see what are the machine is learning, what are the things on this. And you can even build your own callback that you're doing this. And the train batch normalization that I'm doing this. You can set like, it's always set to true because it's always good to do this, but you can set to false. So you can even give other parameters to this kind of a CNN learner. We also have other learners and do this. The HasNet, as I said before, we have like all of this. When you import FastAI, when you do like all vision and everything like this, you can just like type on a cell, just type HasNet and press tab like this. It is also like it has this auto completion stuff like this. Not the. Can I? Okay. Can I? Let me just a second. Let's just show the. This. It's not like. No, I mean it's not. getting out for the share screen, but let me just open a Jupyter Lab instance here so I can show to you. Okay. Oh yes, it's open here. What is going on? Why is it so difficult to do this stuff? Okay. Okay, do I have to close this? Okay. It's really, really difficult. No. Yeah. Here. Okay. I can open so I can show to you. Okay. Okay. From FastAI, you see, you have like the auto completion, vision.all. So import everything. Okay. Shift enter. I hope the computer does not crash. And you see, once it's loaded, it not takes so much time. Okay, it's loaded, and you can just like, if you type you see on the screen, these are like all the HasNet pre-trained models that they have access to this. You can also have like other models, kind of like a VGG. You see, VGG batch norm. These are like already built architectures for you and trained models like this, which is really, really amazing for you to learn this, and it's really useful to do this. You can also build your own model and give the architecture that you built to the FastAI. We are going to use this as well. We are going to explore this as well on the next sessions. So now that I need to see how can I, okay, on this. Oh, yeah, desktop. Okay. What we have? Okay, that's really, really funny, but I want to come back. Okay, let me close this again and open. Open again. Okay, just a second. Just a second. Ah. Any question?
I was trying this auto completion, but
it's not working for you.
Yes, but okay.
Okay, so you are a special case. You are really, your machine is like a really good one for this. And yeah, let's see. Is this one? No, it's not this one. Sorry. Sorry, it's not this. Okay, it's this one here. Yeah. Yes, please. Vasilius, can you?
Hey, yep. I would like to ask you if during this hands-on, are you going to create a model from scratch?
Yes, we're going. We're exactly doing this. I mean, we are already doing this model from scratch, but not for the gravitational waves. But for now, it is for the
Yeah, for the images, but
for the images for the cats and dogs. But we are going to create the from scratch. Like we're going to create the data set, the model, and the machine learning, and try to evaluate this. Okay.
okay. Yep.
Is it sharing? Okay. Oh yes, I can. I forgot to share. Yes. Okay. Now it's sharing. So okay. So where we stop? Towards. Yes. Okay. So as I said, like we have all of this. You can explore more. You can like also see what kind of a loss function that you are going to do this. What is this loss function? This loss function is a way to training our model, train our neural network like this. In the next session, we are going to explore a little bit more what this loss function does. But keep in mind what this loss function gives to us, the information that is how well our models, I mean our machine learning is predicting some sort of image. And with this information, we are going to modify our machine learning models to make even better predictions. So you can check this. And now it's time like to pass your data. Remember that I said that's like before, we have like all the images, and you see like some image that has like 500 by 340, 500 by 375. You see this? That's why we resize. I mean, we don't need to worry about this dynamical change on the models and all of these kind of things. But before we're doing this, it's really good to check what are the best learning rate from this. Why the learning rate? Why the best? We are going to see on the next lectures, but let's say that's like this. Depend on the number that you are giving to your neural net, this learning rate, it can make or break it. I mean, it can give like extremely good results. It can give like 99% of accuracy on this, or it can give like a very shitty results for you. So this is like one of the main, and one of the really, really good things from Fast AI, because you don't need to guess by nothing this kind of learning rate, this kind of number. FastAI has this learning rate defined, which was from a paper from the creator of the FastAI that he's doing this. And what this thing does is just like take some random batch on my data set, put it on the model, and dynamically change the learning rate and recording the loss function, recording the loss value for this. So you say like, okay, one really good tip to give to you is not like give the value for the learning rate where the loss is the minimum, right, like this. Because if I give it this directly, what will happen is the machine will not learn anything at all. It was just like this. However, you can give a learning rate value on the most steeper of the loss landscape, like this. I have like a really beautiful videos and from a website. It's called the Loss Landscape, like this, that shows to you how important these things are and how to deal with these kind of things. But one main take is like this. Okay, take the values that are more steeper, and this will make the model learn more efficiently, right? More quickly and more efficient, like this. So we give this. Yes. Yes.
Question, a stupid question. When I do this, I get the same shape, but
yeah,
different.
Because the batch you are loading is always be different. Yeah, it's always like this. Okay. You have like the same shape, but yes, yes, it's randomly shuffling. It's like take like all of this, but you have like the kind of like of the same behavior, the same shape. Yes, exactly. Yes, it will be a little bit. Yes, it will be a little bit different. To be a little bit about this, but this is normal. This is like the expected behavior like this. Unless I will give you my random seed and everything, and you will have like this exact same value like this. So you are choosing in a region that are giving like the most steeper. The fast I even give you a tip like this. Oh, the learning rate is steeper on this value here, and they're giving this, and you give this function like this fit one cycle. This fit one cycle is really amazing. These are the things that I'm showing here to you. This is like a state of the art. This is not like trivial stuff. This is not like things like a eminist or anything like this. These are really serious stuff and really good stuff. And you see, with only 5 epochs here, just have a look of the error rate like this, the average error rate that we have. Like we have like subhuman error, like 0.004 like this. And yes, it got this on the second epoch like this. It goes like from 1% to 0.4% like this. And I mean, you can train for longer, but you are going to be in a region that we call it like chasing zeros. And you see like it takes like 23 seconds to run each epoch. It's extremely fast, and we get like a really good accuracy on this. What this learning fit one cycle does, I will show in a little bit, and we can see how well our model is giving to us by these showing results. So these showing results will give you like the image, some random batch again, and you give like the true value, like the ground truth of the label, and the predictive value, it is like in the lower like this. And you see it's matching every time that I'm giving like a picture of a cat and a dog, a cat and a dog. It is really learning the things. It's really learning the things that we're supposed to learn. And say, oh, okay, great. I mean, that's amazing. What are these kind of things are doing? The fit one cycle during the training of the loading images, the everything like this, it will dynamically change the number of the learning rate like this, dynamic change on the training phase, and also the momentum like this. Why this? Because most of the time when I'm doing stochastic gradient descent or other optimizer are doing this, it will happen that we fall on a global minimum, and ideally in a global, I mean in a local minimum. And ideally we want to find a global minimum. Why? Because not only our machine will be able to predict the things that she learned on the training data set, but also be able to predict the things that she never saw before. So that's why a global minimum is desired like this. And to kind of like escape from the local minimum of regions, we change this learning rate. We increase this, we increase the step of the learning rate, while we decrease the value of the momentum, because we don't want like the machine keep like so much time with this step longer like this. And we do this kind of a playing, and it helps a lot you to kind of like escape from this local minimum stuff. So we can also check the train loop and everything of what FastAI is doing. And you see like, okay, let's test this with an image that the model never saw before. And this is an image that I took from a cat on the streets. I don't know if it's a stray cat or it has owner, but you see this, the cat is like a kind of like very similar to the, I almost stepped on this cat. My wife saw this, and it was even hard like me to distinguish between these. So let's see if the machine can see this, can figure out how these things are. So I give the image to the model, and the image say, okay, yes, this is a cat. Yes, really useful, 99% of accuracy. And you say, great, my model is working. My model is like, let's give it this another images and get the predictions again. And it says again, like really confident, like 99.999% of accuracy like this. I say, amazing. However, I'm not sure, but this is not a cat, okay? So do you see what is happening here? What you see here? Because my model, I didn't take into account my model, these sideways pictures. I only put like pictures that are like the features. So convolutional neural networks, they are really, really good to catch this kind of translation invariant models. But it will only catch this if you provide this kind of information as well. So if we train our model to take into account this kind of rotation, translational rotation, and other things, it works fine. So, okay, let's not train a model again, but let's just rotate the images. For those of you not know, these are my flatmate. Okay, he's a really, really good boy, and we can give again, and you'd say, okay, now I know this is not a cat, this is a dog. Okay, so just to see these kind of effects, it has like really, really impact on this, and you have to always keep in mind on this kind of thing, because these things, these are dumb as you can get. I mean, this is not like, oh, we're going to be replaced or anything soon. They have become really smart, but they still have some problems that's like this. And we can fool it then very, very easily like this. This image here on the left, these are really nice. When I was in China, we have like these Hong Kong protesters that are doing this. And you know, China is heavily invested on facial recognition algorithms and everything like this. They get really, really good to do this. So, and also people are very creative. So what they did, this is like an art student that he built this kind of image projector that projected images from different people to fool the recognition, the algorithms like this. And on the right, you have like another machine learning application from this guy, Bruno Sartori, is a friend of mine, really, really good guy. And yes, Mariah Carey became Bolsonaro on his vision, just to make full of the end, just to make this. But I mean, you can take some of these politicians and do some really nasty stuff with these models and share and try to influence some. I mean, I'm not giving any idea, okay? I'm just like a hypothetical scenario like this. And this kind of model that built this is entirely built on the fast AI, on the things that we are exploring this. And they are extremely, extremely easy to do this. And the main takeaway is like, okay, at least fast AI handle all the hassle, everything like this, so we can use this in our advantage. And if you have some question, do this. And yes, this was really fun. I received this WhatsApp and I say, okay, this makes sense for me as well. But okay, I'm open to answer a question until I die, okay? So in the next session, we're going to explore a little bit more. I think tomorrow we're going to build our own data set. At least we're going to try. If I'll not be able, I will share to you my data set to training, and we will start to build upon this, like do a more practical stuff, not only classify dogs and cats. Okay, I hope you like it, and that's all for today.
So are there any questions? So the link is well alive, so if there are any questions.
That's because the questions haven't started yet.
From Zoom.
Okay, the question will start when you start to like to install things, running the notebooks and getting errors.
So
it will be like really like. I mean, we have it's not as like it's the what's the name? I always the group that we made, not the WhatsApp, the Discord. We have the Discord group. I mean, we could share on by email if you want to enter. I'm always online. I'm always open this. If I not answer immediately, I soon answer when I get some time. And usually I like to open, like to stream some of my work session, so you can also like see what I'm doing, what I'm working on, and check out what we are doing this. I mean, just don't try to scoop me or something like this. I will not like share sensitive stuff, but yes, that's it. That's it for today, okay?
I don't know if I can ask something, Felipe.
Yeah.
Okay, so I mean, the questions that the students want is exactly, how can I build these models for gravitational waves?
The question will be answered during this week. The question will be, it is exactly the same thing that we did for cat, but instead of the gravitational wave, the cats were replaced with the gravitational wave. They're just exactly the same.
Okay, so the question is the following: is that I understand that people with this first lecture on the methods and so on will have the chance to really go back home and try to really implement in their own computers the stuff. So I guess that tomorrow people will have some questions to you, something like this. So I don't know, but I have the feeling that that people is going just to exercise a bit the things, trying to install the things, the different tools and so on. And tomorrow probably, would you prefer to do this type of chat informally during the first lecture in the morning or in the afternoon, or is there a plan there?
I don't know. I mean, I can start like to do this, and we see tomorrow. We're going to see like
Okay.
this.
Let's see
And,
tomorrow. How does it go?
I think that the main problem that is like it takes a little bit of time to generate the data set. I already have generated one, so I can share, but it's 1.1 gigabytes, and I'm still trying to figure out how to share this. Maybe I share in batches or something, but I will share and I will allow, and you guys will be able to build the things as I did.
Right, because you see, Philip, the thing that I mean, at the end of the week, at least this was one of the things that I had back in my mind, is that people should be able to really understand the methods, really generate the data sets, and trying to figure out how to manage that.
Yes.
So we have these 56 or whatever different signals that we have out there for the O3 run data. And it would be great if people could start looking into these in more detailed way.
And,
I don't know, it's kind of, you know,
if you guys, I think that's why I decided to do the presentation on the Jupyter notebooks, because you guys can download this and you can run. You can do this.
Sounds great, Dan. Sounds great, Philip. Thanks a lot. Huh?
Thank you.
Okay, so unless someone raises the hand or wants to say something, I would say that this is pretty much done for today. You can practice with cats and dogs from today to tomorrow. And
try to do some crazy stuff. Try like to predict the breeds. Like try to build a model with predict the breeds of at least the cats. Try to have some fun with the Jupyter notebooks. I would say like you learn a lot if you try like to experiment. If you give some error, I mean the machine will not explode on your lap. Okay, if you give some error, it's just an error. Try to do this. I mean, most of the time that I want to teach students just like this is this problem, because students get like afraid that it cannot run properly, it cannot run this, it gives some error, and it's just like trying there. I mean, I don't know. At least until now, my machine never exploded, so I'm still alive. So I don't know what kind of machine you have, but I'm pretty sure 99% of confidence level that your machine will not going to explode by running a wrong cell or change the dimension of a tensor or something like this. Okay, just try, just have fun.
Okay.
All right. So just to say, tomorrow we start at 9, and today I declare it's over. And that's it. So see you all tomorrow. And bye-bye.
Yeah, bye.
Bye-bye, everyone. Thank you very much.
Just one thing. I will try to upload this on the YouTube, and we're going to share at least my sessions. I'm going to share on the YouTube. You can try to check the video and try to do this by yourself. And also for my public shame as well.
Yeah, and I don't know, Alexandra, if we could get the lectures this morning uploaded in the agenda. I don't know if this would be possible, and this would be great to have this.
This morning lectures?
Yeah,
I think some of us would prefer to upload at the end of the week to make some minor kind of updates on the lectures. So.
Okay, sounds good then. Okay.
Thank you.
Okay, so bye everyone. Thank you very much.
Bye. See you tomorrow. Bye.
Now my face.
You're looking at yourselves.
Okay.